Hello everyone. Welcome to this session number 4 as part of the training program on Introduction to Python Programming and its applications in water resources sector. In the first three sessions, we have seen installation of Python through Anaconda distribution, then Introduction to Jupyter Notebooks. Then we have seen the basic data types in Python, and then the data structures in Python, namely lists, tuples, um, uh, sets, and dictionaries. Uh, Today's session is on functions, loops, conditionals, and then control flow tools in Python. Um, So functions are building blocks of any programming language. Functions are meant for undertaking specific tasks. So just as variables, we try to give, it is suggested to give descriptive names to the functions, giving the context and making it readable and understandable for anyone who is reading the code. It must be conveyed to him what the function intends to do. And functions make the code efficient, organized, and maintainable by reusing part of the code. Suppose you have a code of multiple lines, a big code. Sometimes it may go up to hundreds of lines. So if parts of the code are doing the similar task, uh, sort of they are repeating, there is repetitive code, then in that in that case the functions come very handy. When the code undertake repetitive tasks, you can define a function and you can replace those lines of the code repetitive doing the similar tasks with the function. You can call the function instead of writing so many repeating the lines. So that way your code will become short. It is a better way, efficient way of coding, and it is better organized, and it is maintainable. For example, if you have to make any change subsequently in those lines, repeating lines, you can simply make the change in the function just one time instead of making changes everywhere in the code where the similar task is being performed. So functions make the code efficient, organized, and maintainable. They come very handy when the code undertake repetitive tasks. There are in Python there are many built-in functions, like we have seen the print function, which prints any statement to the console. And then there are we can also have customized functions or user defined functions, uh, which have a structure uh, like this. Any this is the this is the function header, where any function uh, definition, it should start with the keyword def, which is a short form for definition, define, then followed by the function name. You can give any name, and then followed by parenthesis having parameters, any number of parameters, even no parameter functions may have zero parameters, but there has to be a parenthesis followed by a colon. So this is the function header, which is defining the function name as well as defining the inputs it expects uh, in the form of parameters. When we pass values to the parameters, they become arguments. They are known as arguments. Then followed by the function header, you have function body. The function body, as you can see, unlike in many other programming languages, in Python we don't have these curly braces, and then end of the expressions for semicolon at the end of the expressions. We have a very easy, elegant syntax. Where there are some rules that are to be followed, like you can see the function body is indented, and each line of the function body is indented up to the same extent. Generally, it is suggested to have four spaces. Uh, you can simply use a tab button and you can maintain the consistency. Otherwise, it will throw an error or you will get unintended results. So the function body will have expressions and then each function will return a value, whether there is uh, uh, a return statement or not. If there is a return statement, it means Python says that you have the function is ended here, and even if you have any more statements with the same indentation below the return statement, they will be ignored. So some function may have a return statement, it may not have any return statement, but generally it returns something. It may return none or it may return some value as output. So none is also has a existence in Python. We have seen in case of list methods. We talked about none and none type. The functions there were specific to classes. We have methods. Methods are same. We have talked about string methods. We have talked about list methods and dictionary methods, which can be used with list methods can be used with the list class. So when we will learn more about methods, objects, and classes afterwards. So methods have the same meaning as functions. So when the list methods were altering the list in place, and we have seen by assigning them to the same list, we are getting a none. So functions can return a none also. Then to call on the function, we must pass on arguments to the parameters inside the parenthesis. So whenever these parameters are actually placeholders, and when you pass a value to the parameters, they are known as argument. So functions can be called by passing values to the parameters inside parentheses in anywhere in the code by using the function name, and then within brackets you give the arguments. The number of arguments should be equal to the number of parameters. So if there can be no if there are no no parameters, you need not pass the argument also. So there can be any number of arguments depending upon the function. Like we have seen len length function, it requires exactly one argument. So then variables defined within a function have local scope unless specified by the keyword global. We will see the scope, variable scope part. We will have some examples of these aspects, the user defined functions and scope. Uh, so whenever you are defining variables within a function, they have they cannot be called the outside function. Means the outside function, they are not known. And if you are using a global variable inside a function, sometimes even if you are not passing on the value to a variable inside a function, it executes by taking the global value if the name is the same. So you have to be careful, and you must be clear about the scope.
Let us now create a new Jupyter notebook from Anaconda Navigator. From in the startup menu, you can look for Anaconda Navigator and then click on the shortcut. Alternately, you can also launch Anaconda Navigator from Anaconda prompt with the command anaconda dash navigator. Either way, Anaconda Navigator will be initiated. And here, as we had seen, in the left tab, go to environments. Now the active environment is base environment, which is indicated by this icon, play icon in green. You can activate the Python-WRM environment by clicking on Python-WRM. It is asking for updating Anaconda, a new version of Anaconda Navigator. You can click on remind me later. So now the Python-WRM environment is being activated. Yeah, once it is done, go to home, and here in the applications, listed applications, you can click on Jupyter Lab launch button. Again, it will open the new browser, and you can select the Python IPython 3 kernel, and then save this notebook from file, save notebook as, in the folder Python WRM, in the present working directory /notebooks/ rename your notebook as 3_functions loops control flow, and save it.
So let us see how to. We have seen the structure of user-defined functions. Let us see. Let us create a simple user-defined function and then use it. So we have seen that any definition of let me create a heading first. So in Markdown syntax, the hash sign between the hash sign and the text, there has to be space. Um, Let us define a function, um, sum of numbers, which does the simple sum of, say, integers with two parameters. And this is the function header, which is the def keyword stands for definition, define, and the name of the function, which is sum of integers, we are giving a descriptive name, and then two parameters. It will take two parameters, arguments, x and y are parameters which are placeholders for the and where we can pass the value of integers while calling the function by passing two arguments and followed by semicolon. Then you press enter, and then it automatically it takes indent of four spaces. So you can type the function body. Simply you can say return x plus y. So the function will return the value of x plus y whenever it is called. Let us execute this cell. So the function has been defined. Now how to call the function? You have to simply uh, write the name of the function, and within parenthesis you pass the values, say 2 comma 3. What happens if we execute this? It will print the function is called, and then it is returning the value which is returned by the function is printed below the cell. You can assign it to a variable, like you can assign it to z is sum of integers 3 comma 4, and then you can print z. So if we define a function, and if we are specifying the number of parameters which the function expects as an input when at the time of calling it, the number of arguments should be equal to the when you want to call the function, the number of arguments should be equal to the number of parameters. If the number of arguments are greater or less than the number of parameters, that then it will throw an error. And also the order of arguments is also very important. The arguments they are mapped to the corresponding parameters. Uh, Say if I am passing only one argument into this simple function of sum of integers, and if I am passing say 3 arguments, it will return an error. So the sum of integers function takes 2 positional arguments, but 3 were given. What is this positional argument? As I was saying, the arguments which you pass into the function, they should be in the same order as the parameters. So they correspond to the position. So these are positional arguments. When you don't know the number of arguments that will be passed into your function, there is a way where we have what is called arbitrary arguments. I'm writing a comment. You will not come across this often, but you should be aware. In our course, you will not come across this. So arbitrary arguments, if you don't know the number of arguments that will be passed into your function, you can add asterisks before the parameter name. And then the function can receive any number of parameters, say in the it can receive in the form of a tuple of parameters. They all any number of parameters, they all collect under a tuple. So let us see. I will simply define a function colon, press enter, then which returns, args is short for arguments, which returns the arguments. Uh, if I want to call the function1. Let me pass any number of arbitrary number of arguments, and argument can be of any data type. And if I execute it, you will see a tuple. So I am passing these arguments into this function, and all these arguments are getting collected as a tuple, and the same tuple is being returned. When we do loops in a while, and if you want to make use of any number of arguments, if you want to print all the arguments which are passed to the function, where the number of arguments is arbitrary, we can use loop. We can print it using for loop. We will see it after a while. Then that is about positional arguments and arbitrary arguments. Then there is the something called keyword argument, where you can suppose, let us define a new function. Def welcome participant, which takes parameters first name, last name, then colon, which will print so we will make use of f string. So let us say we define a local variable inside a function. Full name is first name plus space character plus last name. Then you print hello, the variable full name, invalid. Yeah, we need not pass quotation marks in for parameters. Okay, we have defined a function which uh, takes two parameters, first name and last name, and then it does concatenation of strings, and then it prints a hello statement. It prints hello, the name of the person, full name of the person, and how do you do. So now if you for calling this function, you simply type the name of the function, and in case of positional arguments, you have to first pass the argument number 1 will provide the value to the first parameter, first name, and argument second argument will provide value to the second parameter, last name. And however, if you want to go by keyword argument, if you want to input arguments in key value pairs, where each key is a parameter, and the corresponding value is the argument. So here, in such cases, the order doesn't matter. So let us visualize, let us imagine we have a function, a user-defined function with multiple parameters, and you want of various data types, and you want to pass arguments without considering the order. Then you can follow this keyword argument format. So here I will be passing the first last name first. So this is I am specifying the value for the last name. Say I will pass the string Kumar, and then first name I will pass Ashok. So here I am reversing the order. So similarly, if we have many parameters, you can pass keyword arguments in any order, and then I will execute this, which will print this statement, hello Ashok Kumar, how do you do. So that is about keyword argument, and we have seen arbitrary number of arguments. Similarly, there can be arbitrary number of keyword arguments. Say if the number of the keywords are not known, similar to arbitrary arguments, if the then we can define a new function function. You can pass any number of keyword arguments by prefixing 2 asterisks to the keyword arguments, was the short form quarks, KWARGS, and then the colon, and you return so this is our function. Let me call this function. Let me first define a dictionary. It's okay. Let me call this function by passing keyword arguments. Anything like we can have x is 2, y is 3, z is 5. Let us see what happens if I run this. Yeah, a dictionary is getting created. Actually, what is happening is you can pass any number of such keyword arguments. Um, then it will be packed into a dictionary where um the key becomes the key of the dictionary, and the corresponding argument becomes the value corresponding to that key. You just remember these concepts of arbitrary arguments and arbitrary key arguments. Arbitrary keyword arguments. Then we will talk about default arguments. Uh, if you remember, when we were talking about lists yesterday in data structure, we have seen some list methods, and we have used the list method sort. So methods, those are the methods which are there associated with the class list. We'll see the classes afterwards. So the methods are also the same thing as functions. But those methods are list methods which can be applied to on the list. Um, you can let us define a list. For simplicity, I am defining a list of numbers, and now I will, to access the available list methods, I will type period and then I will press tab button, and you can see these are the various list methods. I want to make use of sort. If I execute this, now here you can see that I am not passing anything to sort. um, no parameter is being passed. And if I execute it and print list, so sorting it does sorting in the ascending order. The smallest number comes first, and the largest number comes uh, last. So if actually if we see the documentation, hopefully we should be able to see. Yeah, help. I'm seeing this documentation. Um, the sort method, you can see there are some value arguments which are already assigned in the definition of the method itself. Like false is the value uh, uh, given to the parameter reverse. So they are known as default parameters. So it is sorting in the ascending order. So it is if you want to override this default parameter, you can do that by giving the by changing the default parameter reverse to true, and then you can print list. So now it is sorting in with in the descending order the first number, largest number coming first, and the least number coming last. So just I wanted to illustrate the default. Similarly, when default parameters, how similarly when we are defining the function itself, you can specify the value to a parameter, that is it will become the default argument. So unless specified, it will the default argument will be used whenever the function is called. And if you want to override the default argument, you can do it at the time of calling the function. Then lambda functions, we will just have a look at lambda function. um, Lambda is a keyword in Python. Lambda function has a format lambda, then parameter 1, any number of parameters, colon, and then expression to return. For example, lambda a comma b colon a plus b. And I can pass 1 comma 2 here itself, and I can execute. I can assign it to C, and then print C. Or yeah. So lambda functions, they are different kind of functions which can be used for shortening the code, number one, and number two, as anonymous functions. Like you need not define the full when you are defining the user defined function, you are defining the function and then you are calling again. So here you can use it as an anonymous function which can be used immediately, and you can put it as an argument inside another function easily. So just remember that lambda functions have this format of lambda parameter 1, parameter 2, so on, and then colon, then expression. The expression will be returned, whatever be the number of parameters, this expression will be returned by the lambda function, and whenever you are calling a lambda function. So here we are defining a lambda function having two parameters, and it returns the sum of those parameters. And I am assigning it to a variable C, and I am calling the variables. I am calling the function simply by passing on the arguments 1 comma 2 to C. So this the whole expression can become part of any can become part of an argument to another function without having the need to define a function. That is the utility of lambda. We will try to revisit this. So that is about defining of functions and calling of functions using arguments. And arguments, we have seen the positional arguments and then keyword arguments, the default arguments. Now let us talk about the functions which are provided in a module of Python standard library. Now, when we install Python, uh, automatically the standard library along with its modules get installed. In addition, we have using Conda installer, we have used third-party packages which are not part of standard library. They are, we can say they are part of external library created by users, and then they got prominence because of their utility for handling data like pandas and geopandas. So all these we interchangeably use the word library, module and package. All of them have same conceptual meaning, like each all of they have associated methods inside, and then we can import them into our code and use them. However, actually a library is in Python, library consists of modules, and then package is something which is defined, which is created by a user. Like for example, I can save my functions in a script file. We have talked about script file earlier, and I can call them into the Jupyter notebooks. I can save the script file in the same directory as the Jupyter notebook. When I am dealing with data and I have multiple functions which are of use, then I can call them into the Jupyter notebook by importing this script file into the Jupyter notebook. Um, we have to use the keyword import the name of the script file, and then you can use the functions defined in the script file. So in that is the third party package. In the same way, the standard library has modules, like math module uh, is part of Python standard library, which gets installed with Python. So to make use of there are many mathematical functions inside the math module, which we can make use of them after importing the math module into the Jupyter notebook in our case. Let us have a look at for example, the math module has a function square root sqrt, which takes um, which takes the argument 16, and it should return the value of the square root of 16. However, it throws an error because sqrt as such is not defined yet, because we haven't imported the math module. We can import math module with this statement import math, and then you can make use of the functions which are within the math module. Like now it will return the value of square root. Similarly, you have many mathematical functions, sine. You can have a list of those by pressing tab button on your keyboard. These are the functions, and all the not only functions, but any all the name like math.py is a constant. It is not a function.
You are aware about the pi, which is used for calculating the area of a circle. So it is a constant. So these functions and these constants, these are all part of math module. You can just print the directory of the math to see what all functions and other uh, contents. So these are all the most of them, these are all the functions: LCM, least common multiplier, factorial, the gamma, these log base 10. So these are all various functions, mathematical functions, which you can make use of it by in this fashion. Similarly, as I said, you can define a script, you can define user defined functions, you can save them as a script file, and you can call them and into your notebook, and you can make use of them. Similarly, in the third party packages which we have already installed, we will see that in the next week when we work with pandas, geopandas, we will import them as a whole into our notebook, or we will import some specific functions uh, and then make use of those functions or methods for our purpose. So I think that now that is enough with functions. And one more thing is the scope of variables that we should cover. If I am defining any function, hopefully this will not give any error. Yes. It is a crude way, we are defining the value of x is equal to 5.0, and then we are defining a function doubling of numbers, which takes a parameter a, and we are within the function we are defining x is equal to 2.0. This has this value of x is this variable x is equal to 2.0 has local scope, as it is defined within the function and it is used only within the function. Then we was and the function is actually for returning a into x. We are just making a print statement that within the function, inside the function, the value of x is, we are making use of f string, which we have seen. Then the value of x here, when this print statement is getting printed, it calls the value x, so it will look for the value of x within the in the local scope within the function, and it finds x is equal to 2.0, and then so it prints the inside the function the value of x is 2. And after the return statement, the control comes back to the out of the function, and here when it comes so when the function is called, it will go inside and it will print the statement inside the function. The value of x is 2, and a value of a into x is returned. We are not assigning and printing it, we are not concerned about it. So after the return statement, the control comes outside. Then there is a print statement uh, outside the body of the function, that is print outside the function the value of x is x. Now when it sees here, it looks it doesn't it is so whatever be the value which is defined inside the local inside the function, it had local scope, whereas this statement is outside the local scope. It is in the global scope, so it takes the value, it looks for the value which is defined in the global scope. So here the variable x has a value 5.0 assigned to it, so outside the function the value of x is 5.0. The print statement is getting printed. So it is like scopes have hierarchy. Now whenever a variable is getting defined, it looks for the value of the variable within in the local scope. Say we have a nested functions, and so the innermost function has a variable defined, and first it will look for the value in the innermost function. Then if it is unable to find the value defined in the innermost function, it will look for if it has been defined in the outermost function, then the next level of function. In the same way, it will come up to the outermost function. If the value is defined, then it will look in the global space. So in that way, the scope can be understood. In general, we will not do such things like we are assigning the same. We are using the name of same variable and assigning one value outside the function, one value inside. It is for understanding of the scope. Now, what would happen if I remove this x is equal to 2.0, the definition inside the function? In the first place, it will say x is not defined, I guess. Let us see. Okay, then as I said, in when when we have defined the value of x, we have defined a function which has a variable x, and when the function is called by passing the argument 3
to the parameter a, it will start executing, and it will when it come across the x, it will start looking for the value of x in the local scope. But if it is unable to find the value inside the function, then it will go outside then the next level, and it will find that x has been defined here, so it will take this value. So the inside the here also, within the function also, the value of x, the statement this statement is getting printed inside the function. The value of x is 5. Then again the print statement outside in the global scope, anyway the x has already been defined, has been assigned the value 5. So that is about the scope. Now next, before going to loops, let us have a we have missed one thing about functions. Let's cover it. That is about help option. Like whenever you want information about inbuilt function like len, so you can use this help option, which gives you can use help function and pass the name of the function as a parameter. It gives information about the function. It returns this len inbuilt function. It returns the number of items in a container. We have used it in case of strings, in case of lists and tuples, to find out the length of the string or length or list or uh, tuple. Similarly, for user-defined functions, for better documentation, you can define a docstring, and you place the information about what the function takes as input and what it does and what it returns inside the docstring, so that you can access you yourself or anyone using the your function defined by you. They can access information about the function. Let us quickly define a function and see that. Define product a comma b are two parameters, and it returns a into b. So to include docstring comes just beneath the function definition, and it comes and it is included within 3 quotation marks. So this function takes return the product of two numbers which are either integers or floats. So I have included this line in the docstring. Now if I use this, if I help option, if I call the help function and pass on the name of the user defined function, it prints the same thing which you have included in the docstring. So this way, this is a very simple function which is self-understood. However, if you are defining very complex user-defined functions, you have to, it is always a best practice to document. So even for you to refer on a future date, or for some other user making use of the function defined by you, it will be very useful. Then let's come to loops. So loops are very useful when we want to process large number of files. Say for example, you have a collection of satellite imagery over a long period of time, and you want to calculate normalized difference vegetation index or normalized difference water index, any normalized difference using band math. Each satellite imagery has many bands. Um, uh,
associated, and with normalized difference methods, you can identify you can have quantification of the um, any feature on the earth, like NDVI. It gives an indication about the health of the vegetation, uh, or the presence of the vegetation. So if you want to calculate if you want to perform the same calculation of normalized difference over a large number of files, daily files, suppose spread over many years, so you have to loop. You can use you have to doing the same process over a large number of files. It requires looping. Then for calculation, if you have a table, and for calculation calculation using contents of each row in a table, so such processes require the concept of loops. So loop is a it is a block of code which is repeated for either specified number of times, or until some condition is being valid. Accordingly, there are two kinds of loops: for loops and while loops. For loops, we come across them frequently, whereas while loops are not much used. We will see both of them. We will first see the while loops. So while loops, the structure of while loop is like: while is a keyword followed by test condition, which is tested for every iteration, followed by colon, and the next line is indented. From next line onwards, the body, each line of the body is indented to the same extent. So the body of the while loop is executed as long as the test condition is met, and it will break once it fails, the test condition fails. So let us see. For example, I will define I assign the value 0 to I, and I define a loop using keyword while I is less than or equal to 5. This is a test condition, colon. Then Jupyter Notebook takes indentation on its own. When you press enter, you can print I, and then you iterate. Let us see, you don't give any other um, statement in the body. Now if you execute it, so you have created an infinite loop, because you have assigned 0 to I, and I is always less than 5, less than or equal to 5. This condition is always met. So this whenever the condition is met, the body of the while loop is executed, and once it executes, it again comes back to the control comes back here. It tests whether I is less than or equal to 5, and again it is true, and again it is executed. So it goes into an infinite loop. So to break the loop, you have to press Control C on your or you have to stop the interrupt the kernel by pressing stop button. So let us include an increment statement here. I e I plus equal to 1. It is actually same as I equal to I plus 1. Same as the assignment, I is equal to I plus 1. We are incrementing I every time. So let us run it. So it is um, it is printing 0 to 5. So it starts with the value is equal to 0. The test condition is valid. 0 is less than or equal to 5. Then it enters the body of the loop. It prints 0 gets printed, and then in the next step 0 is incremented by 1. It becomes 1. And after the end of the body of the while loop, the control again goes here. The test for the test condition 1 is less than or equal to 5 s, and again you print 1. Then again 2 is less than or equal to 5 s, and 2 is printed. 3 is less than or equal to 5 s, 3 is printed. Then 4 is printed. Then 5 is also 5 less than or equal to 5 is also true. It is equal to 5. So the 5 gets printed, and when it is incremented to 6, and the control comes back to this point when 6 is less than 5 less than or equal to 5 is not valid, so the loop breaks. So this is how while loop is used. So then let's move forward to for loop. So for loops are used for iterating over sequences or collection of items. Now the sequences can be anything. It can be a string, it can be list of items, list, it can be a tuple, it can be dictionary where iteration can be done on the keys, and it can be a set, or it can be any user defined object which is a sequence. So how the structure of the for loop looks like: the for keyword, then a variable which is used for looping and iterate, then in the keyword, for I in some sequence, some object over which you iterate. It, let us say list. For I in this list, then print I. Yes. So for each for I in this list, so it iterates over each item, each element of the list, and it prints the value of the element. When it reaches the end of the list, the for loop breaks down. So this can be done for any even on a you can iterate over a tuple or a string or a dictionary, and it takes a key. Then sometimes when you want to work with index as well as the value of the sequence that we iterate over, there is a useful function called enumerate. Let us check what it does. So enumerate, it returns an enumerate object. It yields pairs containing a count from the start and a value yielded by the iterable argument. So a count is index, so it returns tuples where first element is the index, whereas the second element is the value associated with that index in that sequence. So for example, if I am passing the same list into enumerate, it returns an enumerate object. If I assign it to any variable, and print that variable, it is not printing the content. So let us make use of it for the for loop and see what it translates. Or we have to use print. For index comma values in enumerate, colon, print index comma value. Yes. So it is so whenever you are printing two uh, uh, expressions or two variables inside by using the print statement, they are printed side by side. So here we are iterating or enumerate the output of enumerate is enumerate object, which contains of tuples of index and value of the list. So when you iterate over it and we are printing index and value, the output is for each element of the list, the value, the index as and the associated value are getting printed on the line, one line. So that is about enumerate function. And sometimes you can also use you may also use range function. You can see the range function. See, it returns an object that produces a sequence of integers from start to stop, exclusive by step. Range I comma j produces I to j minus 1. J is exclusive. So like range 4 produces 0, 1, 2, 3. So you can generate a sequence and you can iterate over for the for loop. Again, you do for j in range of 5. You can simply print j and then execute it. So range of 5 gives an output of 0 to 4, a sequence 0, 1, 2, 3, 4. 5 is exclusive, and in every step the value of j is getting printed, and once it reaches the end of the contents of the range of 5, the loop is terminated. So that way you can also loop over range of numbers. Suppose you want to be selective or looping over range, like you want to specify even the starting, um, like here the default parameter in the range function, starting function. So the start, you can see it is, the default is 0. Yeah, start defaults to 0, means the parameter start in this function range is default argument is given as 0, and if you want to overwrite it, you can do that. For k in range, the start value you can give it as 1. You can print k, so it will start from 1 instead of 0. So that is about loops, while loops and for loops. Let us come to the final part of the today's session, that is on conditional logic and control flow in Python, which is the easiest part. Uh, Let us quickly go see the Boolean data type, which is a fundamental data type which we had seen earlier. There are only two possible values in for Boolean data type, true and false. You can check the type of either, and type of false is bool, which is a short for Boolean. Then not of any Boolean value will return the other value. And logical, the comparison operators, we are well aware about comparison between numerals. What about strings? In case of strings, when you are saying, when you are using these comparison operators, um, they mean the order. Like in order, like in dictionary, A comes first and then C comes later. So when comparison of the strings, first it will start with the first character, it will compare, and if it finds the order is correct, it will return true. And you can similarly, you can compare two strings whether they are equal or not. Uppercase is not equal to lowercase, it will return false. Whether they are not equal, as not equal symbol, exclamation mark, and assignment operator in Python combined is not equal. So as it is true. So these are operators, logical operators, comparison operators, and they have precedence. There is operator precedence. There are logical operators which are and, or, and not, which can be used to combine Boolean expressions. These are all Boolean expressions, the comparison expressions, which will yield a Boolean value. 3 less than 5 and 5 less than 7. If both are true, it should result in true. So you are aware of these operators, and logical operators, and, or, not, and comparison operators. So there is no need to repeat. But one thing which is important to take note of is the precedence of the operators, like less than, equal to, greater, greater than, equal to, and equal to. They are all of equal precedence and they have highest order precedence, followed by not logical operator, followed by and logical operator, and finally or logical operator. That is about conditional logic, Boolean expressions, conditional expressions. And then coming to control flow, till now we have seen the whatever statements or expressions and they used in the code. We haven't considered options, like if a condition is met, uh, some do this, and if the condition is not met, do something else. Such kind of conditions, like using if and else and elif, elef, which is a short form for else if. Using these keywords and with nested if statements, nested if else elif statements, you can have we can take complicated decision makings also can be done using these control flow tools in Python. Not only in Python, in any programming language. And you need to know the syntax of the using these conditional these control flow statements. Like if is a keyword, if and it is followed by a test condition. If it is true, followed by a colon, then in same as in case of loops and functions, the indented portion will get executed below the if the header. Otherwise you can also include an else portion, else block of the code with else keyword followed by the colon for execution of another block of the code. And if you want to have check more than one condition, you can use elif, which is a short form for else if keyword. So let us see one nested loop, one nested conditional if statement. Say for if x is equal to, say, make it simple, x is equal to 7. If x is greater than 0 followed by colon, so the if keyword followed by test condition followed by colon. If you press enter, it will take automatic indentation. Then let us have another if statement. If x modulus 2 is equal to 0 followed by colon. When you are writing nested statements, you just have to take care of syntax. Otherwise, these are very simple statements or expressions. Print f string x is even. Else followed by colon, print x is odd. You can execute and that because 7 is greater than 0, it enters the first the indented block of first if statement, and then it again the condition 7 modulus 2 is equal to 0 is checked. It is not 0, so this is skipped and the control goes to else. Then there is no need for any checking of any condition. If it is not true, then false, this has to be executed. Print f this string that is 7, the value of the variable is 7, is odd, is getting printed. Now we can combine loops and these if else statements, conditional statements. Just to have an example, for I in range of 100, you copy the same block of code. However, you have to take care of indentation. You simply use tab. Obviously, all values in the range of 100. No, 0 is not greater than 0. If I is greater than 0, again you have to take indentation. If I modulus 2 is 0, then you print I is even, else you print I is odd. And you can have an else statement outside corresponding to this if keyword, else there is no need, actually it is not necessary to include else statement every time. Elif we will see one more simple example. So if I execute it, I have to change x to I. So if I execute it, it is iterating from 1 to 99. 100 is exclusive, from 0 to 99, because 0 is not greater than 0, the condition is failed, it will not print anything. It will not, the control goes to the end of the loop, and there is no else statement associated with this if, and nothing gets done. Whereas subsequently for each value in this range from 1 to 99, both these statements are checked and you have the print statements printed. Similarly, if there are multiple conditions to check, you can use elif else if say let us define a dictionary and use the iterate over the keys of dictionary and make use of elif also inside the same thing. Let us say, let us consider a dictionary of elevation of cities equal to Or much better, let us define a tuple of tuples and then you create a dictionary out of it. Pune, around 560 meters. Delhi, around 200 meters. Kolkata, around 10 meters. Mumbai, around 15 meters from above mean sea level. Hyderabad, around 600, which will be in the same range as Pune. Say Darjeeling, it will, I don't know how much, let us say 2000. So this is a tuple of tuples. Elevation of cities is defined. You can check the type. Elevation of cities. Now let us create a dictionary. Is equal to, you can create by inbuilt dict function by passing on the tuple of tuples, elevation of cities, and you can print it. So a dictionary has been created with the keys as the name of the cities and the values as the elevations as the values. Now let us write a simple for loop for city in, we know that we can only iterate over keys in the dictionary, not the values. So for city, because the keys here are cities, we can for readability we can say for city in elevation cities dictionary colon, it will iterate over these 3 4 5 cities. If how to get the elevation, the name of the dictionary, in square brackets you have to pass on the key, that is city. If cities dictionary, if elevation city underscore cities underscore dictionary square bracket city is greater than 1000, colon print f string city is at high elevation, is located at high elevation. You can even print the value of it. Anyway, leave it. Then else if, the short form for else if is elif colon elif condition if the elevation of cities is less than 1000 and greater than 100, then print if city is located at moderate elevation, a medium elevation. Else you need not give the statement test condition, because the rest of the values it is understood. Print is located at lower, higher. So take care of the syntax. Key error city, the key is not defined. Okay. Yeah, I was wrongly giving the quotation marks with the city. So we have combined the for loops with if, elif and else statements. So you can see the Pune, the value 560 lies between 100 and 1000. So the moderate elevation is printed. Delhi, in case of Delhi, again it is greater than 100, so it is moderate elevation. Then Kolkata is at a lower elevation. Mumbai is at a lower elevation because the values 10 and 15 are less than 100. Then Darjeeling is located at higher elevation. So in this way you can combine. It is a very simple example, but we can, when it comes to data analysis, and as well as geospatial analysis, you can have nested if statements, nested loops, and combined and we also talked about dictionaries within dictionaries yesterday. So combining all these, you can have workflows where you can test we can make complicated decisions, making can be made with ease. So that is about today's session on functions, loops, conditional logic, and control flow in Python.
By now we have covered much of the basics of Python, except a few things like error handling, um, some few other topics which we will cover uh, in the next session. You will have an overview of object-oriented programming in general, not specific to Python programming, just to have clarity, conceptual clarity of what is actually the object-oriented programming paradigm is. Subsequently, we will see the object-oriented programming concept in Python, and we will see some of the topics which we haven't covered, like exception handling, some more topics. Then we will also see file handling using Python, file and directory manipulations, reading and writing files. So that should complete the basics. Then we can start with working with data. Uh, Subsequently, we will have sessions on data handling and analysis, data visualization, geospatial analysis using the third-party packages which we have installed through Anaconda distribution. Thank you very much.